And now we come towards the determination of surface tension by Jaeger's method. So it is not necessary to remember this, but how to determine the surface tension, that's more important. Surface tension means that is force per unit length, or surface tension is the tendency of stretching the surface of liquid. This method is based on the fact that the pressure inside an air bubble formed in a liquid is greater than external pressure. So if the radius of bubble is R, then the excess pressure will be 2T over R, where T stands for tension and R stands for the radius of bubble. This excess pressure is measured in the Jaeger's experiment. The surface tension is given by T is equal to Rg over Hd minus Hd. So Hd and d, we are referring to two heights. R is the radius of capillary and H is the difference of the liquid levels in the manometer. So D capital is the density of liquid in manometer. H is the length of immersed portion of the capillary. D is the density of liquid. Means if the liquid is water, obviously its density is 1 gram per centimeter cube or 1000 kilograms per meter cube. From this method, the variation of surface tension with temperature can be studied. From this method, the effect of impurity on the surface tension is also studied. So we are finding here that surface tension is affected by the impurity of the substance. On increasing the temperature, the surface tension decreases. So surface tension is inversely proportional to the increasing temperature. On mixing a soluble substance, the surface tension decreases, for example, the soap solution. Now we have to just undergo the excess of pressure or decrease in pressure due to surface tension. So first is the excess of pressure. There is difference of pressure outside and inside the curved surface of the liquid, as in bubble and drop of the liquid. This is called excess pressure. This excess pressure is produced due to surface tension. So what is the cause of the excess pressure? It is surface tension, that is force per unit length or the stretching property of the liquid. Excess pressure inside the drop of liquid is given by function 2T over small r, where P stands for internal pressure minus external pressure, and internal pressure is much greater than external pressure. So we have taken the difference of the two pressures. Small r is the radius of drop and T is the surface tension. Due to the two surfaces of soap bubble, excess pressure inside will be double of the initial value. That is, initial value was 2T by R and double of that will be 4T over R, where R is the radius of the bubble. Inside an air bubble in a liquid, the excess pressure will be 2T over R. If the radii of the arms of the U tube are unequal, one is longer, other is smaller, then difference in the levels in the two arms will be H1 minus H2, and that is equal to 2T over G into 1 over R1 minus 1 over R2 into cos theta, where theta is the angle of contact, T is the surface tension, R1, R2 are the radii of the two limbs of the U tube, and H1, H2 is the difference in the heights. If a hollow sphere of radius R has a fine hole at the bottom and it is immersed in a liquid, then liquid does not enter the sphere till the force due to liquid becomes greater. That is, upthrust becomes greater than the force due to surface tension. If the critical depth is h, then following formulas are to be used. Pi r square stands for area, h is height, d is the density, g acceleration due to gravity. So pi r square hd will be equal to 2 pi r t cos theta. If theta is 0, then h will be 2t cos theta over rdg, and that can be written as 2t over rdg. And hdg, that is atmospheric pressure, can be given by function 2t cos theta over r. Well, now we are referring to breaking of a big drop. Suppose that we have a big liquid drop whose volume is V, and it is to be broken to the smaller drops with volumes V1, V2, V3, V4 and so on. But for a bigger drop, the volume is 4 over 3 pi r cube, where r is capital, and for smaller drops, we find it will be 4 by 3 pi r1 cube, 4 by 3 pi r2 cube, 4 by 3 pi r3 cube. If we add all the volumes, that is for the smaller drops, it will be equal to the bigger drop. So this concept we have to go through in the breaking of big drop. So the main context will be like this. If a big drop of radius r breaks into up to n small drops, each of radius r, then as volume of the liquid remains constant, volume does not change. So drops of mercury are shown on the table. Smaller drops are spherical. As the drop becomes slightly heavier, we find that it will be stretched more due to surface tension, and a very big drop has larger surface tension. So 4 over 3 pi r cube, as I have explained earlier, it will be n times 4 over 3 pi r cube. So how much is r cube? Because 4 over 3 pi will cancel off from both sides. So r cube will be equal to nr cube. Or to get the value of r, it will be r n to the power 1 by 3. That is third root of n. N is the number of drops. So n is how much? It will be r cube over r cube. That is capital R cube over small r cube. So it can be written as r over r the whole cube. And small r can be estimated, that is r over n to the power 1 by 3. The increase in the surface area due to breaking of big drop into small drops. Now, increase in surface area, that is because of the surface tension. So delta A, small change in area, that is n into 4 pi r square minus 4 pi r square. Now here we have taken as a capital R, minus 4 pi n r square minus r square. So again the same figure is to be consulted, that is smaller drop is shown on the left side, whereas the biggest drop is shown on the right side. As the weight goes on increasing, surface tension effect will be more, so we will find that the larger drops are flat, whereas smaller drops are spherical. Now consider 4 pi into nr square minus r square and multiply this expression by r square and divide by r square. If we do so, then our net expression after division will be 4 pi r square into nr square over r square minus 1. The work done. Now when we speak work done, it is force into displacement. So work done in breaking a drop, that is 4 pi nr square t minus 4 pi r square t. So we can take 4 pi common or 4 pi t common, and the remaining values we can write within the bracket. So our net result is W is equal to 4 pi r square t into nr square over capital R square minus 1. Therefore 4 pi t r square will be nr square over r square n to the power 2 by 3 minus 1. So this equation is further simplified, and the simplified result is written in the last line, that is 4 pi tr cube is equal to 1 over r minus 1 over capital R. When a big drop of liquid is broken up into small drops, then temperature decreases. So big drop broken into small drops, the temperature decreases. And when small drops coalesce together to form a bigger drop, the temperature increases. If a big drop is formed by coalescing in n small drops, then temperature increases, as I have explained to you earlier. Now formation of a bigger drop when n small drops coalesce. So radius of a bigger drop is r, and that is small r into n to the power 1 by 3. Decrease in surface area. So surface area decrease is given by delta A, and mathematically it is given as 4 pi r square into 1 minus nr square over r square. So what we have done, we have multiplied and divided by r square, and the increase in temperature, that will be estimated as 3T over JSD into 1 over R minus 1 over capital R.